the electrolytic cell portion of our lab quiz. We're going to be electroplating, so we have a copper solution. We have a copper electrode hooked up to a battery. We have our power supply. All right, and then that's hooked up to our spoon. Okay, so the mass goes up on the spoon because the copper ions are being reduced onto the outside of the spoon. Okay, we have the power supply is allowed to run for 1800 seconds. So identify the cathode in the reaction. Whatever mass goes up, in this case, we always plate onto the object, that's our cathode. That's the site of reduction. The copper ions are plating onto the outside of it. What's the half reaction occurring at the anode? So we have a copper anode. Okay, the anode always loses mass, goes into solution, so it's going to be oxidized. So we have Cu going to Cu plus 2 electrons. Those ions then get attracted to the spoon because the spoon has those electrons from the battery. What is the minimum number of amps that were supplied by the power supply? So I know the time, amps is coulombs per second. So if I know the seconds, I got to figure out the coulombs. I can figure out the coulombs based upon the mass. The mass of the copper plated is going to be 2.89 grams. So divide that by the GFM is 63.5. That's 0.046 moles copper. Get coulombs, I need to know moles of electrons. So that's X moles of electrons. All right, copper is plus 2, so it's going plus 2, gaining 2 electrons for every 1 copper atom. So now that's 1 copper gives me 2 moles of electron, 1 mole of copper, I should say. So X equals 0.092 moles of electrons. So now to get Faraday's 0.092 moles of electrons is X coulomb. Sorry, to get coulomb, use Faraday's constant because 1 mole of electron is 96,485 coulombs. So I'm going to multiply by Faraday's constant. Our X here is 8,876.62 coulombs. Divide that by your seconds of 1800. And you get 4.0